Welcome to This Explainer. You know, it's actually wild to think about something that touches almost every single second of our modern lives, yet we completely take it for granted, right? You just tap a glass screen and boom, instantly a high-definition movie starts playing, or a message pops up from a friend halfway across the planet. We just expect it to be flawless, smooth, and instant. But underneath all that seamless experience, there's an incredibly vast, super complex system of moving parts. So today, we're going to uncover the hidden mechanics of the internet, and we're going to look at it through a really beautiful lens, as a magnificent global symphony.
Zip, ping, flash. I mean, every single millisecond, all around us, there is an absolute hurricane of raw data zipping through the air. We're talking invisible radio waves bouncing off cellular towers, pulses of light racing through glass fibers right under the street, electrical signals firing back and forth across entire continents. It is sheer, unadulterated, invisible chaos. So, how on earth does this staggering blizzard of digital noise not just result in endless crashes, static, and dropped connections? Like, how do billions of independent, chaotic signals actually combine to create the perfectly smooth, seamless digital experience you're having right at this exact moment? Okay, let's dive into this, because the sheer scale we're dealing with here is honestly staggering. We are talking about billions of individual connections happening every single second. This isn't just a few computers talking to each other anymore. This is a massive planet-wide digital orchestra. And you know, in an orchestra of this unprecedented size, timing, precision, and organization are literally everything. If even a tiny fraction of these billions of connections were out of sync, the whole system would just collapse into a deafening digital roar. To really understand how all this works, here is our playbill for today. First, we'll look at the invisible orchestra. Second, hardware, the instruments. Third, protocols, the sheet music. Fourth, routers, the conductors. And finally, the final masterpiece.
So, let's kick things off with Section 1, the invisible digital orchestra.
On one hand, we have chaotic raw data. Just imagine a room full of musicians tuning their instruments all at once. Someone's banging a drum, a trumpet is just blasting, a cello is screeching. It's just noise. And because no single person or central computer controls the internet, it absolutely requires all these independent sections working together in perfect, synchronized harmony. On the other hand, we have the orchestrated network. This is when those exact same instruments stop, look at the conductor, and play together in the exact same key. The internet's true magic isn't actually the data itself, right? It's the miraculous organization that turns a complete cacophony of digital noise into beautiful, functional harmony.
Moving right along to Section 2, hardware, the network's instruments. Now, what's really interesting about this is how the physical endpoints of our network break down. If the internet is a symphony, then the hardware devices in our pockets and sitting on our desks are the actual instruments generating the notes of our digital music. Think about mobile devices. They make up a massive 45% of the network. They're our string section. They're vast in number, and they carry the main melody of our daily communication. Then you have desktops at 30%. They're the brass section, right? They provide that heavy, powerful processing when we really need to blast through complex tasks. And then there's the Internet of Things, or IoT devices, sitting at 15%. These are your smart thermostats, your connected fridges, kind of like the quirky woodwinds, adding texture and continuous environmental data. And finally, the massive servers at 10%. Those are the percussion and bass. They lay down the deep, foundational rhythm holding the entire performance together. To really ground this tech in our metaphor, just compare your smartphone to a violin. Just like a violin is a physical object that completely relies on the friction of a bow to produce a unique acoustic wave, your smartphone is a physical object that relies on an internal antenna to produce a unique radio wave. By itself, it can only make its own isolated sounds, but when it joins the broader network, it produces the foundational elements, the very first notes of our entire global connection. Which brings us to Section 3, protocols, the sheet music. But how do these instruments actually know what to play? Well, a protocol is simply the shared universal language of the network. It ensures all devices communicate without creating that awful cacophony we talked about earlier. Think of the smooth flowing rhythm of a perfectly timed waltz. 1, 2, 3. 1, 2, 3. Protocols provide this exact kind of vital, rhythmic instruction to our devices. They are the strict, universal rules dictating exactly how a message is formatted, how it's sent, and how it's received. It's the only way to ensure that data from an Apple device flows seamlessly to a Windows device, keeping everything from crashing into one big chaotic mess. And this brilliantly illustrates what happens when we look at TCP/IP. That is the fundamental protocol suite of the internet. Now, to a lot of people, that's just a scary technical acronym. But compare it to musical notation. A treble clef, a quarter note, a time signature. To someone who doesn't read music, that looks like a scary, complex language too. But to a musician, it's just basic instructions on how to naturally play the song. TCP/IP is quite literally just the sheet music of the web. It tells data packets exactly where to go, how fast to travel, and exactly how to behave once they finally get there. But it goes a little deeper when we look at how APIs and protocols actually collaborate. They work hand in hand to maintain the rhythm across wildly different types of software. First off, they establish common timing, which makes sure data isn't sent faster than a receiving device can physically process it. Second, they translate different device languages. It's kind of like a maestro seamlessly signaling both the French horns and the Japanese taiko drums in the exact same sweeping motion. And third, they ensure data packets arrive in key, meaning the data is perfectly intact, uncorrupted, and exactly what the user requested.
All right, let's step up to the podium for Section 4, Routers, the unseen conductors.
Look, every great orchestra needs someone to stand at the front and direct the flow of the music. In our digital world, the entities that direct the massive global flow of our digital music are routers. And the stage they conduct on, it is unlike anything else in human history. It's made up of local ISPs routing traffic in your neighborhood. Massive deep-sea cables, literally thick bundles of optical glass lying quietly on the dark ocean floor connecting entire continents. And massive satellite arrays orbiting right now in the vacuum of space. This is the staggering physical footprint that our unseen conductors use to move the performance around the entire globe in mere milliseconds.
Which makes this quote incredibly fitting. An unplugged router is the digital equivalent of dropping the conductor's baton into the brass section. It's funny, but honestly, it is so true. The absolute second our unseen conductors lose control of the data traffic, whether someone trips and unplugs a cable or a critical server goes down, chaos immediately ensues. Data packets collide, videos buffer endlessly, and the beautiful music screeches to a halting, super frustrating stop.
Let's move to and see how this builds by looking at the actual journey of a single data packet. First, the note is generated by your device. Say, you hit send on a photo. Instantly, it gets routed by your local ISP, which finds the absolute fastest way out of your neighborhood. From there, it's guided through those global cables, perhaps crossing an entire ocean under the waves. And finally, it arrives perfectly timed at its destination, reassembling flawlessly on your friend's screen. It beautifully mirrors a musical note traveling from the stage, bouncing off the carefully designed acoustics of a concert hall, and landing perfectly in the audience's ear. And that leads us to Section 5, experiencing the final masterpiece. All of this invisible chaos, all of this complex hardware, strict protocols, and global infrastructure, it all ultimately serves a single purpose. And it is totally amazing to track how our digital symphony has evolved its tempo over time to meet that purpose. Think about it. We started with the slow, clunky adagio tempo of dial-up modems. Remember those awful screeching connection signs? Then we moved to the allegro, the much more confident walking pace of early broadband. Then came the lightning-fast presto of fiber optics. And now, we are fully immersed in the ultra-high-speed era of 5G. The music has just gotten faster, richer, and infinitely more complex. So the crucial point is simply this. The ultimate goal is the beautiful, seamless music of a flawless video call or an instant download. When you're on a video call with a loved one across the world and there is absolutely no lag, no buffering, and you have perfect picture quality, that is the internet operating in complete, breathtaking harmony. Millions of routers, billions of protocols, and thousands of miles of cable, all working together perfectly just to give you that simple, flawless masterpiece. But the concert is far from over. As our devices multiply, with smart cities, artificial intelligence, and billions of new sensors coming online every day, what will the next movement of our digital symphony sound like? Will it be an entirely new genre of connectivity we can't even imagine yet? It's a fascinating thought to leave you with. Thank you so much for joining me today to explore the mechanics behind our digital world. Keep questioning, keep learning, and hey, the next time you stream a video, take a second to appreciate the magnificent orchestra playing right there in the palm of your hand.